So as you can see, today we're going to be graphing log functions. Just a quick review of the functions, some of the functions that we've studied the graphs of all year long. The quadratic function, we draw a parabola. We know that the vertex is going to be at HK, and the A, if the A is positive, it opens up. A is negative, opens down. If the A is a big number, it's a vertical stretch. If the A is a smaller number, 0 to 1, we have a wider graph, vertical compression. So it doesn't change. The A, the H, and the K don't change their purpose no matter what the function is. So if you remember, the H and the K happen to be the inflection points on the graphs of cubic functions. And again, the A is really super narrow or thin vertical stretch if the A is a big number, and then it's more of a kind of a wider vertical compression if the A is between 0 and 1. And if the A is negative and small, like between 0 and negative 1, then it's the graph would go down, decrease from left to right, and it'd be compressed, so it'd be a little bit wider. And then on the rational functions here, so we have this rational function that the H and the K still provide some guidelines for us. In fact, on the rational functions, the H and the K happen to be our horizontal and vertical asymptotes. So there's still a point HK, but that happens to be where the asymptotes cross. And then we would draw the graph just like that. So the A, the H, and the K always provide us with some important information about the graph, where it is, and things like that. So when we flip on over to exponential and log functions, we still have the A, the H, and the K. And we learned in the beginning of this unit that we've got this point on this key point on the graph of an exponential function. We know though that the horizontal asymptote, so the horizontal asymptote is always going to be y is equal to k, and the key point happens to be, so this is kind of a neat thing that we haven't really talked about, but the key point, if you look at the exponent, then if you can make the exponent equal to 0, so in this case x would have to be, the x coordinate of the key point would have to be h to make the exponent 0. And then if you let x equal h, then you have 2 to the x, so you have 2 to, so let's do it over here. So we have x and y. So if you let x equal h, you get 2 to the h minus h, which is 2 to the 0. So you really get a times 2 to the 0, which is 1, plus k. So actually the y coordinate of the key point is a plus k. And not that we need to remember that too much, but because you can always just plug in whatever value for x that makes the exponent 0. And anyway, when you do that, you know that if a is positive, that the graph opens up. Oops, that was not very good. Try that again. So we know that the graph of an exponential function starts slowly and then grows very fast after that. And we've been dealing with the coronavirus here. I'm at home making this video, and that's exactly what's happening. Still, that the number of cases is growing exponentially. So we've seen plenty of graphs like that if you've watched the news. Anyway, the key point, again, we have the key point being at h, comma a plus k, and the horizontal asymptote, again, is this y equals k. So that's the graph of an exponential function. Now, a logarithmic function, if you remember that the log of 1 is equal to 0, so this is your bread and butter, the log of 1 is equal to 0. So if you can make that if you can make that argument equal to 1 by choosing the correct x value, we're going to do that in the following videos. If you can make that argument 1, then it simplifies what the y value is. So it takes the log all the way out of it, because as soon as you get log of 1, that's 0. So anyway, here's the key point on the log graph. The log graph has a key point of, and we'll get to that actually. Let's talk about the vertical asymptote first. The vertical asymptote is x equals 0, but if so whatever makes the argument 0, so it's actually x equals h. So the actual log base 2 of x, y equals, we have this graph, and the graph looks like this. So we know that y equals 2 to the x has a horizontal asymptote at y equals 0, and y equals log base 2 of x has a vertical asymptote at x equals 0. So again, the vertical asymptote is x equals 0, and the key point is at 1, 0, and the key point in general, if you think about it, x equals whatever makes x minus h equal to 1, x minus h equal to 1, so when x is equal to h plus 1. So when x is equal to h plus 1, then that takes away the log, that makes the log expression 0, and you just get k. So I would caution you at remembering, caution you at remembering those coordinates of the key point, because all you have to do is remember to find an x value that makes the argument equal to 1, and then you can easily find the y coordinate of that key point. All right, so we're going to make another video for the transformations of these functions, and we will see you in the next video.